In this example, we are going to consider area bounded between two curves x equal to gy and x equal to hy. And we are looking at the area of the region bounded by x equal to y squared minus 2y minus 3 and y equal to x minus 1, which is same as x equal to y plus 1. We shall first look for the point of intersection. So we can call this equation 1 and this equation 2. So if you equate equation 1 and equation 2, you can just replace the x by y plus 1. So you consider y plus 1 equal to y squared minus 2y minus 3. So that will give you y squared minus 3y minus 4 equal to 0, which you factorize will give you y minus 4 y plus 1 equal to 0. So y is 4 and minus 1. And when y is 4, you can look for x. X is 5 plus 1, so it's 5. When y is minus 1, x will be minus 1 plus 1. Minus 1 plus 1 will be 0. X is just 5 plus 1. So next the point intersection will be 5, 0, and also 0 minus 1. Next is a sketch a graph of x equal to y squared minus 2y minus 3 and y equal to x minus 1. You can look at y equal to x squared minus 2x minus 3. This is same as x minus 3 x plus 1. So which means if you draw this graph, it should cut at minus 1 and 3. If you set this to 0, you get x is 3 and minus 1. So it should cut at minus 1 and 3. So it should cut at minus 1 and 3. So if you sketch the other curve, so if you sketch x equal to y squared minus 2y minus 3, then it should look the other way around. You just interchange your x and y axis. Then it should look like this. So you cut at minus 1 and 3 at the y-axis. So you keep this in mind. And also the intersection point is 5, 0 and 0 minus 1. Intersection point is 5, 4. So you keep this in mind. It's 5, 4 and 0 minus 1. And the curve looks like this. So I have redrawn it here. So the curve of x equal to y squared minus 2y minus 3. And then you draw in the line y equal to x minus 1. Y equal to x minus 1 will be a line like this. It will look like this. Here will be minus 1, here will be 1. Y equal to x minus 1. So you just draw it in. And you realize it's actually the intersection point, 0 minus 1. It's actually the intersection point. So you should draw it here. So the line y equal to x minus 1, when you draw it in, it should look like this. And then this point here should be 5, 4. So which means if you go down to the y-axis, here should be 4. And then now it's clear that what you want is this region. So it's from minus 1 to 4, the y value. So which means to find area, right, you can just integrate from minus 1 to 4. So to find area, you just integrate from minus 1 to 4. The top curve is the line, which is x equal to y plus 1. So it means it should be y plus 1 minus the bottom curve, the red curve, which is y squared minus 2y minus 3, then dy, which is same as integrate from minus 1 to 4 minus y squared plus 3y plus 4 dy. So that will give you minus y cubed over 3 plus 3 over 2y squared plus 4y, and then you sub in upper limit 4, lower limit minus 1. If you sub x as 4, it will give you minus 64 over 3 plus 24 plus 16 minus, you sub y as minus 1. So it gives you 1/3 plus 3 over 2 minus 4. And after that, you can simplify this to 125 over 6. 125 over 6. So just sub y as 4 and sub y as minus 1. You give you 125 over 6. So for this question, you do it about the y-axis is easy. If you do it on x-axis, then you find it's more complicated. You can try it out. See whether can you do it about x-axis instead of y-axis. About y-axis is very easy. The top curve is just x equal to y plus 1. The bottom curve, the red curve, is just x equal to y squared minus 2y minus 3. Then of course you have to sketch a curve of both of them. For x equal to y squared minus 2y minus 3 and x equal to y plus 1. You have to look for intersection points, especially the y value, which will be the lower and upper limit of your integration. And then the final answer, the area is 125 over 6.